Hello, good evening, students. Today we will study this classification of polymers. We had already studied in the previous lecture this classification based on origin of polymers, then classification based on structure, and classification based on intermolecular forces. Today we will study this classification based on mode of polymerization, then number of monomers and biodegradability. So these types of classification we will study today. So the fourth type of classification of polymers based on intermolecular forces. We know mechanical properties of polymers like tensile strength, then toughness, elasticity. They are differ widely and depending upon this intermolecular forces. The polymers are classified into various categories on the basis of intermolecular forces. So the first type of category of polymers on the basis of intermolecular forces, these are elastomers. So elasticity is the property by which substance get stretched by external force and restores its original shape on release of that force. This property is called as a elasticity. Then elastomers are the elastic polymers. They have weak van der Waals type of force and which permit the polymer to be stretched. A few crosslinks between the chains the help stretched polymer to retract to its original position on removal of applied force. Example of this elastomer is vulcanized rubber, then Buna S, Buna N, and neoprene. These are the examples. So the first type of polymers based on intermolecular forces, these are elastomers. We know under this coming this very good example, we know these rubber bands. So here by stretching this and by releasing force, again it gives the original shape of this polymer due to this weak van der Waals force present between intermolecules and crosslink. They help to stretch the polymer and retract to its original position. Remember these examples well. Vulcanized rubber, Buna S and Buna N, and the neoprene. Second example of this type of polymer is fibers. This polymeric solids which form threads, these are called as a fibers. So what are fibers? Fibers are polymeric solids which form threads. These are called as a fibers. Fibers possess high tensile strength, which is the property to have a resistance to breaking under tension. This characteristic is due to the strong intermolecular forces like hydrogen bonding, then strong dipole-dipole attractive force. Due to this strong intermolecular force, the fibers are crystalline in nature, and example of this polyamide, example is polyamides and polyesters. Example of polyamide is nylon 6,6 and polyester is terylene, that is commonly called as a dacron. Then third type of polymer based on this intermolecular forces is thermoplastic polymers. This plasticity is the property of being easily shaped or molded. These thermoplastic polymers are capable of repeated softening on heating and hardening on cooling. This is important property of thermoplastic. They become soft by heating and hard on cooling. These polymers possess moderately strong intermolecular forces and the intermediate between elastomers and fibers. These properties are in between first two types of polymers that we had already studied. These are elastomers and fibers. So thermoplastic polymers have property in between elastomers and fibers. Example of this type is polythene, then polyester, polystyrene and polyvinyls. These different bottles, these are coming under this type of thermoplastic polymers. Thermosetting polymer is differ from this previous type, thermoplastic. So these thermosetting polymers, these are rigid polymers. During formation, they have property being shaped on heating but get hardened while hot. So this is a different property than thermoplastic polymers. On heating, the shape can be given, and in hot condition, they becomes again hard. The previous type, that is a thermoplastic, they are soft on heating and hard on cooling. So this thermosetting is a soft on heating, and in the hot condition itself get hardened. Once it is hardened, this becomes infusible, cannot be softened by heating. So by further heating, it cannot be softened and therefore cannot be remolded. So shape cannot be changed. This characteristic is the result of extensive cross-linking by covalent bonds. Why this type of property is present in thermosetting? Because of presence of covalent bonds between cross-linking form in the molds during the hardening or setting process in hot condition. Example of this type of polymer is bakelite, then urea formaldehyde resin. These are the examples. Then the next type of polymers. So under this, on the basis of intermolecular forces, the polymers are classified into four types: elastomers, fibers, thermoplastic polymers, and thermosetting polymers. Now the fifth type of classification of polymers, this is based on different monomers. Which type of different monomers are present, on the basis of that, these polymers are classified into two types, that is homopolymers and copolymers. Homo meaning the same. So polymers which have only one type of repeating unit, only one type of monomer, this type of polymers are called as a homopolymers. They are formed from the single monomer. In the some cases, the repeating unit is formed by condensation of two distinct monomers. So two units get joined and then it becomes polymerized. So example of this type is again polythene, polypropene, nylon 6, polyacrylonitrile, and nylon 6,6. These are coming under this homopolymer type. Second type is copolymer. The polymers which have two or more types of repeating units, they are called as the copolymers. So what are copolymers? The polymers which have two or more types of repeating units are called copolymers. They are formed by polymerization of two or more different types of monomers, presence of each other. The different monomer units randomly sequenced in a copolymer, and example is Buna S and Buna N. These are the examples of copolymers. So that is about the fifth type of classification of polymers based on number of monomers. They are classified into two types, that is homopolymers and copolymers. Then the last type, that is the sixth type of classification, is classification of polymers based on biodegradability. So most of the synthetic polymers cannot be affected by microbes. These are called as a non-biodegradable polymers. So the polymers which cannot be degraded by using microbes, these are called as a non-biodegradable polymers. These are in the form of waste material which stays in the environment for very long time and causes the pollution. Most natural fibers, in contrast, this biodegradable. In attempt to this tackle the environmental problem, the scientists have developed biodegradable synthetic polymers, and these are given in the table 15.5. So 15.5, this table gives the examples of biodegradable polymers, and these are synthetic polymers which can be biodegradable. So table 15.5, that gives the biodegradable type of polymer. That we will study in detail. Thank you.